In 1967, a postgraduate student at Cambridge University named Jocelyn Bell Burnell was conducting a radio survey of the sky using a newly constructed telescope. Her task was to analyze vast amounts of data recorded on long rolls of chart paper, an often tedious process of scanning for irregularities. After several weeks, she noticed something unusual, a peculiar signal that stood out from the background noise. It was not random. It pulsed. The signal repeated with astonishing regularity, once every 1.33 seconds. Initially, it was dismissed as interference, perhaps originating from human-made sources. But as further observations were made, the signal persisted with unwavering precision. It did not drift, it did not fade, and it did not behave like any known terrestrial disturbance. It was coming from space. What made the discovery so extraordinary was not merely the signal's origin, but its consistency. No known natural phenomenon at the time produced such perfectly timed pulses. The possibility, however remote, of an artificial origin could not be ignored. The source was humorously, but not entirely unseriously, named LGM-1, short for Little Green Men. Even Burnell herself briefly entertained the possibility that she had detected the first sign of extraterrestrial intelligence. As it turned out, the explanation was no less remarkable. The signal originated from a rapidly rotating neutron star, a dense stellar remnant left behind after a supernova explosion. These objects, now known as pulsars, emit beams of electromagnetic radiation from their magnetic poles. As they spin, these beams sweep across space like the rotating light of a lighthouse. When aligned with Earth, they produce the precise pulses that had been observed. The mystery was solved, but it left behind a profound implication. The universe is capable of producing signals that, at first glance, appear artificial. This realization helped catalyze a scientific endeavor that continues to this day, the search for extraterrestrial intelligence. For decades, astronomers have been scanning the cosmos for signs of artificial transmissions. Yet, despite increasingly sophisticated instruments and methods, no confirmed signal of extraterrestrial origin has ever been detected. Meanwhile, humanity itself has been broadcasting its presence into space. For nearly a century, Earth has been leaking radio waves, television broadcasts, radar signals, and other transmissions into the cosmos. These signals expand outward at the speed of light, forming an ever-growing sphere roughly 100 light-years in radius. Within this bubble lie thousands of stars, any of which could host civilizations capable of detecting our presence. Beyond this region, however, Earth remains silent. Ironically, as our technology advances, our radio signature is diminishing. Modern communication systems are far more efficient and less prone to leakage than their predecessors. As a result, the Earth may soon return to a state of relative radio silence. If other civilizations follow a similar technological trajectory, their detectable phase may be fleeting. A brief window in which they emit signals strong enough to be noticed before transitioning to quieter, more advanced systems. Even at its peak, Earth's radio leakage is incredibly faint. As it travels through space, it spreads out and weakens, becoming increasingly difficult to detect. Only the most powerful emissions, such as military radar, stand a realistic chance of being observed across interstellar distances. Future observatories like the Square Kilometre Array aim to push these limits further. With unprecedented sensitivity, such instruments may be capable of detecting radio signals from civilizations hundreds of light-years away. But beyond that range, passive listening may not be enough. To be detected across vast cosmic distances, a civilization may need to actively announce its presence. One approach is the construction of powerful, omnidirectional beacons, devices designed to broadcast signals in all directions. However, maintaining such a beacon would require enormous amounts of energy. A more practical alternative would be highly focused transmissions aimed at specific targets. In 1974, the Arecibo Observatory transmitted a deliberate message into space. Directed toward a globular cluster approximately 25,000 light-years away, the broadcast lasted less than 3 minutes. Any civilization in the path of that signal would have only that brief interval to detect it, and no opportunity for repetition. The likelihood of such a message being intercepted is exceedingly small. Nevertheless, there have been intriguing moments. In 1977, a powerful radio burst known as the WOW signal was detected. The signal was strong, narrowband, and appeared to originate from deep space. Yet despite extensive follow-up observations, it was never detected again. Its origin remains unknown. On the off chance that it was artificial, a reply was transmitted in 2012 in the general direction from which it appeared to originate. Whether anyone or anything was listening remains an open question. Given the vastness of the galaxy, the probability of two civilizations detecting each other through such brief, uncoordinated transmissions is vanishingly small. To improve our chances, scientists have begun to look for indirect evidence of life and technology. The discovery of exoplanets has transformed our understanding of the universe.
Since the first confirmed detection in 1995, thousands of planets have been identified orbiting distant stars. We now know that planets are common, and many reside within habitable zones where conditions may allow liquid water to exist. Water, as far as we know, is essential for life. By analyzing the light passing through an exoplanet's atmosphere during transit, scientists can infer its chemical composition. Certain gases may serve as biosignatures, indicators of biological activity. For example, oxygen is abundant in Earth's atmosphere due to photosynthesis. However, oxygen alone is not definitive proof of life. It can also be produced through non-biological processes. More compelling evidence may come from combinations of gases that are unlikely to coexist without continuous replenishment, such as methane and carbon dioxide. These chemical imbalances could point toward active biological systems. In addition to biosignatures, researchers are searching for technosignatures, evidence of advanced technology. These could include artificial satellites, large-scale industrial pollution, or even massive engineering projects. One such concept is the Dyson sphere, a theoretical structure proposed to encase a star and capture its energy output. This idea aligns with the Kardashev scale, which categorizes civilizations based on their energy consumption. A Type I civilization harnesses the energy of its home planet. A Type II civilization utilizes the full energy output of its star. A Type III civilization commands the energy of an entire galaxy. Despite extensive searches, no evidence of such advanced civilizations has been found. This absence gives rise to the Fermi paradox. If the universe is so vast and so old, why does it appear devoid of intelligent life? Numerous explanations have been proposed. Perhaps life itself is common, but intelligent life is rare. On Earth, it took billions of years for complex organisms to evolve. The emergence of intelligence may require a highly improbable sequence of events. Alternatively, there may exist a great filter, a stage in evolution that is extremely difficult to pass. If this barrier lies behind us, humanity may be among the few to have overcome it. If it lies ahead, it could explain why civilizations tend to disappear before spreading across the stars. Other hypotheses suggest that advanced civilizations may turn inward, focusing on virtual realities rather than physical expansion. Some may transcend biological existence altogether, evolving into forms beyond our comprehension. Closer to home, humanity has begun sending physical artifacts into space. The Voyager 1 carries a golden record containing sounds and images of Earth. Yet even traveling at tens of thousands of kilometers per hour, it will take over 40,000 years to approach another star. A more efficient method of exploration could involve self-replicating probes, machines capable of reproducing themselves using local resources. Such probes could spread exponentially, exploring the galaxy in a relatively short time on cosmological scales. If any civilization had deployed such technology, we might expect to see evidence of it. Yet the solar system appears conspicuously devoid of such probes. In 2017, an interstellar object known as Oumuamua passed through our solar system. Its unusual shape and unexpected acceleration sparked speculation about its nature, including the possibility, however remote, that it was artificial. More conventional explanations, such as outgassing of unusual materials, remain far more likely. Ultimately, our understanding is limited by a fundamental constraint. We have only one known example of life: Earth. With a sample size of 1, it is impossible to determine how common or rare life truly is. The discovery of even the simplest life elsewhere, perhaps beneath the icy surface of a moon like Europa, would provide a second data point and fundamentally reshape our understanding. Until then, we are left with uncertainty. The universe is vast beyond comprehension, and our search has only just begun. The apparent silence may not reflect an absence of life, but rather the limitations of our methods and perspective. To conclude that we are alone, based on such limited evidence, would be premature. In many ways, our search for extraterrestrial intelligence has been compared to examining a glass of water and concluding that the oceans contain no fish. We have barely begun to explore. There are countless avenues yet to be pursued, new frequencies to scan, new technologies to develop, new methods to refine. It is entirely possible that a slight shift in our approach, a different angle, a more sensitive instrument, a broader perspective, could reveal a universe that is not silent at all, only waiting to be heard.